So here we are, we're outdoors. Hopefully it's a nice bright day, moving a glider around, trying to keep it in a straight line. So let's have a look at this question. So there's the question. Now for this one we were given a diagram, so let's just reveal the diagram. So we have two forces, P, which acts at this point here, and Q, which is acting at that point there. And what we're trying to do initially is to find the resultant moment clockwise about W. This is this point here. If we look at the force P, it has two components. A component which is directly in line with W, and a component which is perpendicular to that line. So in terms of the moments, it's this force here, this component of the force, which is having an effect on the moment, and that's an anti-clockwise moment. So if we look at the clockwise moment of force P, it's going to be that component of P, which is 400 sine 37, and then it's multiplied by its distance, which is 4 meters, but that's going to be a negative number because it's anti-clockwise. Q, on the other hand, can be broken down into two components, one directly in line with W and one in that direction. The one directly in line with W will have no moment. The one in this direction will be 200 times Q cos, 200 times cos 72 multiplied by the distance, which is 14 meters. So the total, or the resultant moment clockwise, is Q times the cos of 72, which is that component there, multiplied by its distance from W, which is 14, that's clockwise, and then we've got minus P, which is P sine 37, which is that component, multiplied by this distance, which is 4 meters. So the resultant moment clockwise is negative 97.7 Newton meters. So we're asked now to decide whether the glider will turn clockwise or anti-clockwise. Well, if we've got a negative clockwise moment, then it will turn anti-clockwise. So finally, we don't want it turning anti-clockwise. We don't want it turning. We want it going in a straight line. So we're going to apply this additional force here, F, in that direction to the tailplane. And in order for things to still be in equilibrium, that force F needs to create a moment which will counteract this moment here. So we need to have a resultant moment of 0. So therefore the force F needs to produce a moment of 97.7 Newton meters clockwise. So F times the distance, which is 14 meters from W, has got to be equal to 97.7, and from that F is around about 7 newtons. Not very much of a force, but gliders aren't very heavy things, and there we are, 14 meters. Is that long for a glider? Might be. Okay, so there we are, that's that question.